This is a review for Chapter 8, 13, and 14. We're going to start out with looking for the vertical asymptote. A vertical asymptote goes up and down, so we look for the denominator to equal 0. So x minus 2 equals 0, x equals 2. Vertical asymptote. Horizontal asymptote, you typically look at your fraction and set the numerator to 0. No, take a step back. Take that back. You look at the degree. You look at the degree of the top and the degree of the bottom. The degree of the top is smaller, so it would be 0. But you're going to add a 1 to that, so you're going to be y plus 1. On this one, your vertical asymptote is setting the denominator to 0. So you get x equals 3 over 2. To determine the horizontal asymptote, you look at the degrees. The degree is 1 and 1, so you use the leading coefficient, which is 1 over 2. Here we're going to look for the vertical asymptote. You set the denominator to 0. The degrees are the same, so you use the leading coefficients. So it's 2 over 1, so we call that y equals 2. Looking for x-intercepts. X-intercepts are where the numerator equals 0. So here, because 4 can't equal 0, we have none. No x-intercepts. The vertical asymptotes are where you set the denominator to 0. So x equals plus or minus 2. So you have two vertical asymptotes. In this case, we're looking for your x-intercepts. So we are going to factor we're going to get x and x, minus 3 minus 4. So x equals 3, x equals 4. There's going to be two locations where this graph crosses the x-axis, at 3 and at 4. The vertical asymptote is where you set it equal to 0. Set the denominator equal to 0. The square root of 36 is 6, so you're going to have two vertical asymptotes. You have two x-intercepts and you have two vertical asymptotes. Looking for the graph that matches this equation. Well, I look at this equation and I see that the horizontal asymptote is going to be, the degrees are the same, so you use your leading coefficient. So 1 over 1 is 1. So we need a horizontal asymptote of 1. So far that looks like this graph is the only one that has that. Then we have a vertical asymptote by setting the denominator equal to 0. So at x is negative 2 and x is positive 2. Again, that looks very promising that A is your graph that represents that equation. Number 9. This says to write an equation for the given relation. G varies directly with T and inversely with M. Well, I'm going to write down a few things here. G varies directly with t. That's going to look like g equals a t. Now let's say that g varies inversely with m. We would say that that was g a over m. So now if we're going to do this problem, g varies directly with t and inversely with m. We're going to get g equals at divided by m. On the back side of the worksheet, we're going to divide these two fractions. We'll turn this one over 1 so that now we can specifically say we're dividing fractions. We need to factor. So it looks like we're going to have x plus 6, x plus 3, they multiply to be 18, they add to be 9. We're going to multiply by the reciprocal. So we are going to flip this one over. So I'm going to write this one here. So we get x, negative 6, and negative 3. They multiply to be positive 18 and add to be negative 9. And this one comes down here. X and x. We get positive 3 and negative 6. You need more negatives than positives. So negative 6. They add to be a negative 3. And they multiply to be a negative 18. So now it looks like we can cross out a few things. Okay, maybe that's all it, oh, I'm sorry. Thought something else might cross out. So we get x plus 6, x minus 3. And the next one, we have to factor. This top is a little trickier to factor. Just as a reminder, you would have to factor, you have to multiply the 3 times a 1. What multiplies to be 3 and adds to be 1, but 1 and 3. So if we were to factor that, we would put down 1x plus 3x plus 1. That's rewriting the 4x as 3 and 1. That's two numbers that multiply to be 3 and add to be 4. Then we'll factor by grouping. The x gives us 3x plus 1. Factor out a 1, which leaves us with 3x plus 1. Remember, what's inside the parentheses has to be exactly the same for factor by grouping. So we factored out x plus 1 is sitting here, and 3x plus 1. So that's the factoring of the numerator. The denominator is a difference of perfect squares times the flip of this. So if x plus 1 is on top, it's now going to be on bottom. We're going to factor this one apart. A little bit easier to factor because the leading coefficient is a 1. This one had a 3, made it trickier. What multiplies to be 12 and adds to be 8? 2 and 6. So we can cross out the x plus 2's, cross out the x plus 1's, and we're left with 3x plus 1, x plus 6 over x minus 2. Moving down to chapter 14, we're trying to identify which equation goes with which graph. What I notice here is this definitely looks like a cosine graph. It starts up high and it goes low. This looks like a sine graph. And currently this one looks like a sine graph. Interesting. Okay, so we have two sines, which gives us two sines and one cosine. So I'm thinking that these two here are going to match. This has an amplitude of 3. Okay, so your A equals 3. All three equations, A equals 3. This goes from, this is pi over 2. That's halfway, so this is pi. So it looks like the period is pi. So we know that period should equal 2 pi divided by b. Well, you look up at your equation, and b is the value in front of the x. So, if my period is pi, I'm going to cross multiply and then divide by the pi. And I know that my b has to be 2. So I have a 2 here. I have a half, so that rules that one out. And my cosine here is a 2. So this is looking like the cosine graph with an amplitude of 3 and a period of 2. So this is definitely y equals 3 cosine of 2x. Let's look at the next graph, what we would have here. We have an amplitude so my A equals 3 again. It goes up to a height of 3. It also goes down to a negative 3, which is also an amplitude. So the amplitude is 3. It looks like a sine graph. If this is pi over 4, this is 2 pi over 4, 3 pi over 4, 4 pi over 4, which is known as pi. So it's also taking the typical parent function of 2 pi and cutting it all the way down just to be 1 pi. So if the period is supposed to be 2 pi divided by b, my period is pi, just like we have just done, we can see that the b value for this should also be 2. So it needs to be a sine graph with an amplitude of 3 and a b value of 2. So that looks like this first one. Y equals 3 sine of 2x. Which process of elimination leaves us for the last one, but I'll work it through us for us so you can get an understanding. This is your amplitude. This is your A equals 3. All three equations had that. Looks like a sine graph because it starts at 0, then it goes to a max and works its way down. This is 1 pi, 2 pi, 3 pi, 4 pi. This looks like it's twice as long as a normal parent function. So if the period equals 2 pi divided by b, and our period is 4 pi, multiply by the b, divide by the 4 pi, b is going to equal 2 over 4, which is 1/2. The b value has to be a half. So that justifies why we have y equals 3 sine half x. because the b value is a half. So putting in our numbers now, we have number 1 was b, number 2 was graph C, and number 3 was the first graph A. So more information than you need to know probably, but that might help remind you how this all works. So we come on over to statement number 5, or question number 5. What's the period? Well, we're experts at that now. Okay. The period equals 2 pi divided by b. That's your b value. Y equals a cosine bx. So what is the period of 2 pi divided by 2/3? The period is going to be 2 pi times 3/2, which is known as 3 pi. The amplitude, the height, the a value is 3, so it's clearly 3. For this next equation, the amplitude is your leading number. This is y equals a sine of bx. So your a value is pi, not a typical value you have for an amplitude, but it works. The period equals 2 pi divided by b. We don't know what the period is, but we have a b value which is 2. So the period equals pi also. So that means that the graph is going to climb up a height of 3.14, go down to a negative 3.14, and back to 0. It's going to come over to a pi over 2, and it's going to end at pi. So that's how that would be possible.